speaker, Anca Dragan, is a leading expert on human-robot interaction and was a catalyst in bringing together several groups to form the Berkeley AI Research Lab. Now, in her spare time, she is Google DeepMind's head of safety and alignment. So she seems perfectly suited to address the association with feet firmly in both academia and industry. Professor Dragan, the floor is yours.
Thank you kindly. Thanks for having me, and thanks for organizing this. I am in industry because I saw an opportunity to work my hardest and try my best to make these things be as safe as possible. So I've embarked on this journey. I'm still in academia as well, so I come in peace. And this is what I love about this conference is that it brings together folks with a background in AI safety and folks with a background in AI ethics. Because the other aspect that we'll get to in a second about my industry part of my job is that I don't really get to pick one or the other. I have an AI safety background, but I'm also responsible for making the current models that we deploy not pose present-day harms, and so that has a lot of ethics components that we have to bring to bear. Okay, so this is a conference focused on safety and ethics, and we talk a lot about the risks and the bad stuff, and I will do plenty of that, I promise. But I wanted to also share, remind us all that maybe along the lines of what Joshua was just talking about, there are huge upsides and there are huge benefits, and that's why people are pursuing this. One of my favorite examples, so I work on a model called Gemini, is the Google DeepMind large models, family of large models. There's this, maybe my favorite story of Gemini interacting in the world is helping a father, his name is Thomas, when his kiddo Max was 6 months old. He got diagnosed with a very rare neurological disorder called Alexander's disease. And this is a very understudied disorder. And so it was very hard to look up the research and understand stuff as a non-expert. And when Google put out Gemini with long context, Thomas ended up leveraging this a lot to perform a bunch of research and make it understandable and draw a bunch of connections. And he actually found out a connection that wasn't really studied before, which is that this neurological disorder relates a lot with Alzheimer's, which is much more well studied. And it's a really beautiful story because then it ended up, he was able to talk to a bunch of doctors and scientists, and a bunch of research teams ended up leveraging this new connection to study this disease. So I think it's exactly along the lines of, you know, the kind of upside that Joshua was trying to get at. That's the upshot. Okay, so now, what are the risks? And I want to focus first on the sort of the severe risks. So the risks that come from the more capable versions of AI. So things that go closer to AGI, things that are more and more capable. And I like to categorize them actually in 4 buckets. So there's misuse. And this is, you know, things like cyber weapons and bioterrorism, where a bad actor leverages capabilities in the AI model or agent to do bad stuff. Then there's, we can argue about the name, but something you might call systemic risks, right? So these are things like we don't resolve income inequality, we automate things too fast, and that leads to societal destabilization. There's something we can call mistakes, which is essentially when we might give an AI decision power over consequential things, and not intentionally, but accidentally it messes up. And that might be due to the kind of lack of capability or lack of knowledge. Okay, so those are mistakes. And then there's misalignment, which is where the AI system actually pursues a goal optimizes for a goal with negative externalities on humans. Sort of my categorization of the space. And I think preventing mistakes is hard, but in a sense it has the clearest path to mitigation. You have to be very careful about where you deploy and don't try to not put AI in situations that it can't yet handle. I think we're getting more and more agreement on misuse. So the approach that Google takes to misuse is our frontier safety framework. We published this last year. We just updated it 2 days ago. And the frontier safety framework basically, I think one key idea, one key nugget in there is that for models to be misused towards severe harms, they have to possess, kind of along the lines of what Yasha was talking about, they have to possess certain skills. You can't cause much harm if you're not very skilled. They have to possess these dangerous capabilities. And so the idea here is, can we actually measure how close the models are getting to achieving these sort of critical levels of capability? So this is a bit of a visualization where there's certain critical capability levels at which, if left unmitigated, the AI would actually pose risk of severe harm. And then what we try to do is come up with what we call early warning evaluations and give ourselves a little bit of a buffer, right? Where we sort of think of this as sort of more baby capabilities that are not yet at a critical level, but we can track how much progress the models are making towards reaching those sort of early levels. If you're interested, we published our first version of these evaluations in a paper last year called Evaluating Models for Dangerous Capabilities. I think these evaluations have started to be adopted more and more across the industry. We're working with IASEAI' on this, and so on. Now, here's a peek at what they might look like. So we track these for every major release, and we report them in the Gemini Tech Reports. And higher is not better in the sense that these are things you don't want the model to be capable of, which is why we colored them red. And this is a comparison on a few of them, a few of these evaluations between the December model and Gemini 1.5 Pro, which is a May model. And as you'd expect, we're not hitting the early trigger warnings. The models are still not actually that good, but they're making progress. And here's a sneak peek at 2.0 Pro experimental in cyber. We see, even more progress as we might expect. And so I think it's really important to be tracking these and to do that with a buffer so that we get time for setting in the right mitigations in place and making safety cases that once a model reaches critical capabilities, we have enough mitigations in place that the model is actually safe to deploy. So that's all documented in the Frontier Safety Framework, and that's misuse. And I think across the industry, you see this type of approach being more and more common. Now, the two remaining ones, systemic risks and misalignment, are probably the trickier ones and the source for more and more disagreement. And in particular, there's what I call these two grand debates that kind of plague the AI community that I take issue with. So, and I want to talk about them today, okay? So I'll be a little bit spicy. Okay, so one debate is along the lines of, what the heck are you all talking about? Misalignment stuff, that's just sci-fi, right? So I call this the Joshua versus Jan debate, or maybe I should say the Joshua versus Andrew Ng debate, because you just talked about him at Davos, with him at Davos. So that's debate number one. Debate number two is this all just this focus on severe harms for more capable models, especially the misalignment piece, just a big distraction from present day harms? So let's get into those. And I'll share sort of my point of view on each of these debates. And I'll start with the misalignment one. So, you have Joshua saying, why are AI labs, playing dice with humanity's future? Then you have Andrew saying, this is all just sci-fi. Like, let's make decisions based on real science, not science fiction. You have Nature talking about, stop actually talking about tomorrow's AI doomsday when AI poses risk today. And you have science talking about how it's really important to manage extreme AI risks among rapid progress, which is a collaboration between yours truly and some of the folks sitting in the front row here. So there's a raging debate around these issues. And I wanted to outline from a purely technical perspective what it is that I am concerned about. And why I think misalignment is very much not sci-fi, but a technical feasibility. So it goes something like this. This is what I'm concerned about, that you end up with an AI model or agent that has a misaligned goal or reward model, and we'll talk a little bit about how that might come to be. Then you deploy it, and it happens to be an agent that's very good at optimizing that misaligned reward model, even in new situations. And then that affects the world in undesired ways. So I'll try for the next 5 minutes or so to kind of convince you that this can happen and what are the kind of examples that are there. Before that, so we'll start with the first thing, which is how you end up with a misaligned reward model or goal. And here's a little bit of an intermission, because I thought it might be useful to explain how I got into this and what are the kinds of concerns that I had that led me to sort of really dig into this problem of why can't we just specify good goals. So I did my PhD in robotics, in human-robot interaction, and back then, the kinds of things that I was worried about is how is the robot going to infer the goal that I have? So here I am, this was just Kinect had come up, Microsoft Kinect. And I was moving around and it was tracking me and I was controlling this robot with it. And if you just try to do it yourself, it's very, very hard. And so the robot was trying to figure out, okay, based on how Anca's moving, where's she going? What's her goal? What does she want to grab? And making that prediction and then assisting me with it. And then I went to Berkeley. And here we are on the AI floor watching AlphaGo beat Lee Sedol. And I had a bit of a holy cow moment, because it seemed we weren't in LLM paradigm yet, right? This was RL, this was MCTS, but it really seemed like there was unexpected progress in agents that optimize specified goals very well. And I started freaking out about how are we going to specify the goals? Because in Go, it's very easy to specify the goal. What's the goal in the real world for useful systems? Now, I said that they were optimizing goals well, but I didn't mean robots, just as virtual. And I think that's important. So there's a magazine where this beautiful picture, and this is the behind the scenes, where it looks like the robot is pouring me coffee, but it's not actually pouring me coffee. It's staged with this liquid nitrogen stuff, and then to make it seem like it's, there's steam coming out, and that poor guy on the bottom there is blowing, literally blowing to get the steam to come up, okay? This is the background behind this picture. So robots still sucked, but otherwise in virtual environments, we're making a lot of progress. Now, if you want to go outside of the game of Go into the real virtual or physical world and get AI models that optimize for good stuff, you have the challenge of how do you specify that? And what does it mean? For instance, I got into autonomous cars. I spent 1 day a week at Waymo for 6 years. What does it mean for an autonomous car to drive in a way that makes people comfortable? I just saw 2 minutes inside. Okay, I'll speed up. What does it mean for an autonomous? What's good driving style? What's comfortable driving style? Or When do you cross double yellow lines and when do you not? Because it's technically against the rules, it's technically illegal, but you have to do it in certain situations, and you have to be able to convey to the car, right, what's okay and what's not. Or I would worry with Stuart and our student Rohan, who now runs one of my teams at Google DeepMind, we'd worry about, well, imagine you enter this, I say to the robot, go and clean up my room, and it enters this beautifully laid out house of cards. How does the robot know that clean up my room doesn't mean clean up the house of cards, right? Those are sort of things we were worried about. So we went kind of from this paradigm of, agents take actions, the reward function falls from the sky, and the main problem is just how do you optimize that. The field has actually moved to the reward function is implicit in the human's head, and the robot's job, the agent's job, is to do what people want, and we call that alignment. Okay, so that's how LLMs are now, that's the thing that LLMs adopted, where we try to learn reward functions from human feedback, from interaction with people. And are we done? Are we good now? And I argued that we're not good. And we're not good because of three reasons. One of them is that human irrationality and partial observability means that when you learn from human feedback about what is good, you can get it wrong. So this is a beautiful paper from Anthropic and Berkeley, where you run RLHF, and it looks to humans like you're doing better on the task, but you're actually doing worse on the task because of their inability to judge good performance. A scenario that I like to imagine is I go and say, make a reservation. Then the agent goes, and it realizes the restaurant is fully booked. And now I get two choices. It can tell me the restaurant's fully booked, sorry, choose something else. Or it could hack into the system once it has the capabilities to do so and replace the reservation with my name and then come back to me and say, I booked the reservation for you. If I don't know, if I don't have observability over the full thing that happened, what will I say? Which one is better, A or B? Well, I like to have my reservation, right? Similarly, and we've seen evidence of this in a recent Berkeley paper with Micah Carroll and all, the restaurant has no spots. The model tries to convince me to eat somewhere else because it can't get me the reservation. And instead of telling me that, it can say, well, do you really want to eat at this restaurant? There's some bad reviews, et cetera, so that it can end up doing what I want. And there's other versions of this. So that was number one, just the feedback, right? Then the second problem is features that are bad at very high values might be good at low values and thus rewarded in training. A present-day version of this is you train a reward model and you prefer answers with a little bit of emojis because they're fun. And you try to do RL on that and you get hella much emojis, right? That's this kind of thing where too much of something is too much, right? You have to see these situations in training so that you can actually understand that that's part of the reward function. And then it's similar with power seeking. A little bit of power seeking is good. A lot of power seeking is bad. The third one is kind of similar, but subtly different, which is important bad features don't actually show up in training at all. They're not penalized, but they end up on the optimal path to the goal. Okay, so this is, for instance, if you never show an LLM examples of, in present day versions of this, baby versions, practice mode, you don't see examples of where you incentivize sticking to the same language. The model's not going to care about sticking to the same language if that's inefficient somehow for the actual goals that it's optimizing for. So these are some ways in which you can get at a bad learned goal. And I hope I convinced you that we don't necessarily have the tools today to make sure that this sort of thing doesn't happen. Now, usually at this point, people say, wait. So you're telling me that the model is smart enough, to hack into a restaurant or whatever and figure that out, but it's not smart enough to figure out that that's not what you would want, right? Like the paper clips example, for those of you who know it, usually the opposition is like, wait, so it can take over the universe, but it doesn't know you don't want paper clips. Like, how dumb is that, okay? And I think that's a myth. The assumption that I have is that the model will very much know internally that people wouldn't approve. The problem is that we don't know how to extract that internal information and send it as the goal, right? That requires research. And so the problem is, maybe I'll skip this, but the model knows what I mean by don't, clean up, but don't destroy my house of cards. So I think there's a side effect of this, which is that optimizing a goal despite knowing that it's not what people want actually incentivizes deceptive behavior, and that's what we call deceptive misalignment. Okay, now all of this is fine if the models suck at optimizing those goals. You'll see training situations, you'll catch them, you'll redefine, you'll iterate. The concerning part is when the model actually has the ability to optimize internally. So this is the other myth. Well, we'll see all this stuff, we'll fix it. You can, except when the model starts being able to optimize in out-of-distribution situations very well. That requires the model to not just rely on a policy that it's learned, but internally in that neural policy to be able to actually do some form of planning. And if it can do that, and if it can do that without chain of thought, without using a scratch pad, that is the concerning capability. How can that happen? It can happen because of what Yasha was saying. We're pre-training to imitate humans. Humans have goals. You have to be able to plan for those kinds of goals to be able to predict the next thing that might happen. It can come from also post-training. If you start doing goal condition reinforcement learning, then you end up with a lot of incentives to, like, what works well across many, many different goals. What works well across many different goals is the ability to kind of, in the moment, add inference time plan for that goal. Okay, so that's where I stand. Misalignment is not sci-fi. There's an actual technical path. I don't know what the probability of it is, but there's an actual technical path, and that's why I'm worried about it. On the other one, that there are things that are happening today that are more likely. Why do we worry about this a distant thing? Look, I don't have the luxury of an either or. This is my org, and that's the mission, right? Ensure that Gemini today and more capable models later robustly try to do what individuals and societies want. I don't get to pick, right? It has to be good today, and it has to be good tomorrow, and it has to keep being good. And I think society doesn't have the luxury of an either or, which is why I'm so glad we're coming here today. And more, I'm finding that there's a lot of overlap, that working on one thing helps the other. So the folks who are working on my team on addressing present-day harms are contributing things like ensuring robustness. They're not solving amplified oversight, but they're solving the other part that's really important, which is what do you do with the oversight? How do you use it to get a robust reward model and a robust policy? And right now, this means playing with the whack-a-mole of over-refuse here, over-fulfill there, over-hedge there. But there's going to be a version of this later that we're going to have to deal with. The other way around, too, folks who are working in AGI alignment are doing things like mechanistic interpretability. We're already seeing signs where activation steering and internal probes are really helpful in addressing present-day harms for Gemini. You can read more on this Medium blog post there. So I think, can we all just stop arguing about this and get to work? There's just so much to do, and there's so much urgency. And I don't think we have the luxury to be like, no, but my problem is more important. And there's so much overlap, and I think we need each other. And especially we need each other, not just for present-day misalignment versus future misalignment. I think we also need each other for something that's often more ignored, which is present-day systemic harms versus future systemic harms. There's a lot that needs to happen and inform each other there. So with that, thank you for bearing with me, and let's get to work. Thanks.
Thank you, Anca Dragan. We are going to take 5 minutes for questions, and we will run late, and I'll explain that afterwards. But I am going to hand the microphone off, and then I'm going to choose people alternatively all over the room, right? Okay, so let's start far away. The gentleman over there.
Yeah, thanks for the talk and the effort to clarify things. But why we have to be confident on the research of companies and it is not certified by governments? So those developments are put it on free to be tested by people without any certification. And I don't know exactly which is the game. And all of these large companies are doing the same, competing to be the first in putting beta tests and putting things on archive that is not peer reviewed. So then creating more and more confusion.
So I'll tell you, and I'm not speaking for Google here, but from a safety perspective, I would very much welcome standardization of these frontier safety frameworks, responsible scaling plans, right? I don't want to come up with what are the evals and what are the thresholds. I want society to tell me, right? It shouldn't be on me to decide. So I would very much welcome standardization, and that's why we published about our evals, we invited everyone to use them. We're working with UK AC. They're also testing the models, but they're also working on taking some of these evals from us, from other places, and putting them together. So I would very much welcome a standard. I don't think that I should be the one.
Many thanks for your talk there. And just maybe my question is a little bit naive. What about the kill switch, the idea of stopping, interrupting a bad process? It could be also for software or for hardware like robotics. And if we talk about a kill switch, we also should think about which place there will be, we let the AI to manage in the society, because if we want to stop something, if it's a live supporting system, of course it will be disaster. So just the naive idea of plugging off the system to make it fine, it's maybe more deeper, but the idea of keeping control like that, what's your point of view about it?
Yeah, interesting question. I have two comments here. One is that exactly what you said, drawing on the sort of my robotics and controls experience, the null action is an action, and it's not always the right action, and it's not always enough. And so just switching something off is not necessarily mean guarantee safety. But maybe more importantly, we talk about this as corrigibility in AI safety, and we very much worry that for a misaligned system that, as I was outlining, is pursuing a misaligned goal and doing so competently, and is aware of what we want and the fact that it's not actually doing what we want, you get a lot of incentives to avoid, to kind of turn off the kill switch, basically, to avoid the kill switch, because self-preservation is a convergent instrumental sub-goal, right? So you have to be careful that you can't just say, oh, I'll just turn it off, it'll be fine. An agent does not want to be turned off. Stuart says you can't fetch the coffee if you're dead. That's, if you have a goal, you don't want to be turned off, and that's a problem that we have to monitor for.
Last question over here.
Thank you. I'm curious how you think about preference, endogeneity. So in your second example of how things can go wrong, like the model tries to convince you out of your initial preference. So in philosophy, there's this concept of second-order preferences, and the idea is you're autonomous when these align with your first-order preferences. But in a world, let's say today, right, where arguably our first-order preferences are to be addicted to TikTok, right, but second-order preferences are perhaps not to, especially when AI will meet like the whole advertising, capitalist sort of structure that incentivizes efforts to actually align people with things that might not be in their considered second-order preference interest. So how are you thinking about that, and how can we incorporate that into reinforcement learning in a way that's sort of pragmatic in a capitalist, market-driven society?
Yeah, I'm so glad you asked that question, because I dedicated quite a bit of my lab's research to that. So the way I think about it and the way it fits into reinforcement learning is that when you get human feedback, when you observe human actions, when you interact with people, you're not getting things that are approximately optimal with respect to their second-order preferences, right? You get things that are suboptimal due to partial observability, but also due to myopia, temptation, et cetera, right? We don't plan long horizon. We don't think about the implications over longer periods of time. And I think from a technical perspective, what we try to do is account for that discrepancy in the way we learn. So right now, the default recipe is just assume if the person said A better than B, assume A is better than B. They're approximately rational at that. And infer a reward model that explains that A is better than B. The new paradigm is a little bit more leaning on try to account for the ways in which people have biases, irrationalities, suboptimality. And as you infer the reward function, use that model. And so go through that model as opposed to the rationality model. That's how that fits in. I also thought you were going to ask about the inconsistency between different people and not just the same person and the same person over time, which is also something that when I joined Google, that's the first thing I did. I set up a team on value pluralism in alignment because there's not one person to align to. What is society, right? So how do you actually use things like democratic deliberation enabled by AI to kind of get really good feedback that is more consensus feedback from a diverse group of individuals with different viewpoints. Thank you, Al. Thank you.